Hi guys, and welcome to the latest in the preliminary chemistry video series on the topic of metals. This is number 4, reactions involving metals. In this video we're going to look at some of the different types of reactions between metals and other substances. We're going to look at them in two ways. We're going to look at a general equation which describes any metal reacting with one of these other substances, and then we're going to look at specific examples. So the three that you need to keep in mind here are metal plus dilute acid, metal plus water, and metal plus oxygen. Now for metal plus water, we will carry out an experiment to distinguish between whether there's a greater reaction in cold water or in warm water, and we may even do the same thing involving cold or warm acids as well. So the first group that we want to have a look at are the metal and dilute acids. So this is the general equation. And the general equation is useful because it allows us to start from a point where we can start substituting any individual examples of metals or dilute acids. So the general equation is that a metal plus a dilute acid produces hydrogen gas and a salt. So here's an example, magnesium and hydrochloric acid. So this would form hydrogen gas, and we try and name the salt if we can. So the salt comes from the metal, which is the first name, magnesium, and the second part of the name comes from the anion that's formed when the acid loses its hydrogen ion. And so chloric indicates that this is a chloride. So the specific example of magnesium plus hydrochloric acid would give us hydrogen gas and magnesium chloride. Now this is quite a long messy thing to write in words, so we can also write it as an equation. In this case, H2 represents the gas, and you could put the subscripts underneath as well. So this would be solid for magnesium, aqueous because it's a dilute solution, so that means it's been added to water, or water's been added to it. And hydrogen is a gas, it will come off as a gas, which we can test with a pop test. And then the other product is our salt. So this is what we just said before is magnesium chloride. Now we need to know how to write the formula for magnesium chloride. So in order to do this, we get our periodic table out. We notice that magnesium is in group 2, so therefore it will have a charge of 2+. Chlorine is a halogen, it's in the second last group, so it will have a valency of -1. In order for these to be balanced, the formula for magnesium chloride is MgCl2. Magnesium chloride is soluble in water and therefore it will remain in aqueous solution. Before we leave this, it's probably important to make sure that we balance the equation as well. At the moment I have one magnesium on one side, but I only have one of each of the hydrogen and chlorine, and I have two H2 here, is two hydrogens, and two here, which is the two Cls. So therefore, in order to balance this, I need to put a 2 in front of the HCl. So now my equation is balanced. So our next general reaction is metal plus water. Now you can think of metal plus water as an example of a very, very dilute acid. So metal plus dilute acid gave us hydrogen gas and a salt. The difference this time is if we look at water as being instead of writing it in its normal manner, H2O, we write it like this, HOH, then it's written in a way that makes it look a little bit more like an acid, where we have hydrogen and we have an anion. The OH is the anion. So what this means is that this salt here, the metal hydroxide, is just a salt that we get in the same general equation when we're looking at metal plus acid. So metal plus acid from the previous slide gave us hydrogen gas and a salt. The difference this time is the salt, because we're using water, the salt is always going to be a hydroxide. And so our salt is a metal hydroxide. So again, if we do the same example and add magnesium, we're still going to get hydrogen gas, but we're also going to get magnesium hydroxide. And that will be our salt, but the salt that we produce when we're reacting water is always going to be a hydroxide. Some metals are more likely to react with warm water than they are with cold water, and some metals will react either way, just faster if it's warm. So let's again see if we can write an equation for this process. The hydrogen gas comes in as H2, and the magnesium hydroxide, we said before magnesium is a 2+ ion. Now hydroxide is one of these polyatomic ions, or a radical that is more than one atom that retain an overall charge. No easy way of doing this, not at this stage of the course, so it's important then just to try and remember that hydroxides have a -1 charge. So therefore, just as we did with the chloride, we need 2 of those in order to balance the 2+ of the magnesium. Again, we need then to check that the equation is balanced. So 1 magnesium on this side and 1 on this side is fine. We've got 2 hydrogens here and 1 oxygen. Here we have 2 and another 2 over here is 4 hydrogens and 2 oxygens. So therefore we need to put a 2 out the front of the water in order for this to be balanced. And again, it's important too to try and keep remembering about your subscripts. So magnesium is a solid, the water is a liquid, the hydrogen is a gas, and the magnesium hydroxide will be in aqueous solution. So our final reaction is metal plus oxygen. In this case, no hydrogen gas is evolved because there is no hydrogen, and we need to remember that we can only produce products from the combinations of what's present in the reactants. Okay, it's the law of conservation of mass, and we can't create atoms that weren't there. So in the case of metal plus oxygen, we have 2 elements we're adding together to form a compound, and that compound will be a metallic oxide. So to be consistent then, if we choose for a third time magnesium as our metal, and we're adding oxygen, then we're going to form magnesium oxide. The equation for this process, magnesium is a solid, burns with a very bright flame. Excuse me. It burns with a very bright flame in the presence of oxygen to form magnesium oxide, MgO. Again, each time we write a formula now, we want to start trying to think about whether or not we've got the right combination. For the third time, magnesium is 2+, and I've explained why it's 2+. The oxygen is going to be a 2-, and that's because it's in the third last of the groups, 2 in from the halogen group, so it's group 6 or 16, depending on which system you're looking at. And so this time, the ratio remains as 1:1, and magnesium oxide will come as a white smoke and left behind as a white solid powder. So this is our general equation. It's not balanced. We have 1 magnesium and 2 oxygens on the left side, and we only have 1 of each on the right side. So therefore we're going to need a 2 in front of our magnesium oxide in order to balance up the number of oxygens. But that's going to mean we've now got 2 magnesiums on the right side, on the product side. So we're going to need 2 out the front of the magnesium in order to double that as well. So very important that we are balancing the number of atoms of our reactants and the number of atoms in our products. And the law of conservation of mass is what we use to ensure that all the different atoms can be rearranged, but we have the same number on both the reactant and product side of our equation. So here's an example. Consider the reaction between sodium and water. Write the chemical equation for this reaction. So when you're considering these sorts of questions, you look at what substances we have present. Now, sodium is a metal, and so in this case we're adding a metal and water. So our general equation is metal plus water gives us hydrogen gas plus a metal hydroxide. So this is our general equation. Now we'll look at it specifically. So specifically, the metal is sodium, and it's going to be a solid. We're going to add that to water, which is a liquid. We're going to produce hydrogen gas, H2, it's the form for hydrogen gas, and a metal hydroxide is going to be NaOH. Sodium's in the first group, so it has a valency of +1, and the hydroxide group we saw from an earlier slide has a -1. So therefore, the formula for sodium hydroxide is actually NaOH, and it will be in aqueous form. So then we check to make sure that everything is balanced. I have one sodium here and one sodium here. I have two hydrogens here, and I have two hydrogens here, and another one here. So that means in total, I have three hydrogens. So it's not balanced, and I have one and one. So what I'm going to need to do is I'm going to first of all need to double the NaOH. So when I double the NaOH, I double my number of oxygens, and I also double my number of hydrogens, and of course the sodiums as well. Now how did this help? Well, this helps because we now have 4 hydrogens altogether, so I can place a 2 out the front of my water. That makes 4 hydrogens altogether, but it also means I now have 2 oxygens, which is good because I have 2 oxygens as well. So I have 2 oxygens, 4 hydrogens, which is correct. I have 2 sodium, and I only have 1 over here, so therefore I also need a 2 out the front, the 2 here. So a little bit more messing around for a balancing of this equation. 2 Na solid plus 2 H2O liquid gives us H2 gas plus 2 NaOH. Thanks for watching.